Odyssian technology has developed a smart pipeline network called Sensor Pipeline. This includes smart components such as the sensor seal, the sensor sleeve, sensor spacer, and sensor composite repair. This is the sensor seal. It is a smart seal having sensors capable of detecting leaks, impacts, and a reduction in sealing force. This particular seal was designed and developed to demonstrate a below-ground seal. You can see that there is a cable within conduit coming out of the seal. When buried underground, this cable travels up to a sensor node, or S node, which contains the electronics needed to support the seal's sensor suite and also to integrate it to the network. A unique feature of the sensor seal is that it has a redundant or secondary sealing element that is also capable of sensing if someone has loosened the seal. If the sealing force is reduced because someone is tampering with it, trying to loosen it, it'll set off an alarm. This is a wireless sensor seal that is under development. This particular design configuration supports both Zigbee and Wi-Fi. The sensor node is actually integrated within the seal itself, so we don't have a separate sensor node utility box. This type of seal would ease installation when you have a large collection of smart seals within a facility, such as a pump station or a compressor station. This is the sensor sleeve. The sensor sleeve is designed to be either a secondary containment structure or a collection basin that houses sensors that detect leaks, earth movement, or impacts. The sensor sleeve can be used in many applications, such as over repairs, flanged fittings, valves, expansion joints, or it can be placed over pipe that's been hit or is flawed. This particular sensor sleeve was designed for use with refined product or gasoline. It includes sensors that detect the presence of gasoline vapor using a unique sensor that was developed by Odyssian technology. It also includes a second method of leak detection for validation purposes that includes the use of microelectromechanical systems or MEMS pressure sensors that would detect a change in pressure due to a leak. This sensor sleeve also has impact or earth movement sensors. You can see that there is a conduit coming out of the sleeve housing. This is because this particular smart sleeve was designed to represent a below-ground sensor sleeve. The cable would travel up through the ground to feed a sensor node, which houses the electronics needed to support the sensor suite and to support integration to the network. What you see in the upper right corner is a patented smart composite pipe repair technology. It is a repair system that involves thermal fusing thermoplastic composites onto pipe or containment structure. The sensor composite repair system includes embedded elements that aid in its processing, as well as sensors for integrity monitoring. When this repair system is used in conjunction with sensor sleeve, the structural and seal integrity of the repair can be monitored through the sensor pipeline system. This is a sensor spacer. This smart spacer is similar to conventional cased pipe spacer, with the exception that it includes sensors to monitor integrity and to detect leaks. Casing spacers are used to support inner carrier pipes relative to outer case pipe. This particular sensor spacer, which is green, has sensors as part of its construction to identify the accumulation of gasoline within the annular spacing. The sensor spacer may include other environmental and integrity monitoring sensors. Each one of the below-ground smart pipeline components has a sensor node or S node. Cables that are attached to the smart pipeline components go up through the ground to the sensor node enclosure. Inside the S node enclosure are the electronics that are needed to support the sensors that are integrated within the smart components. It also includes the electronics needed to make the S node networkable. Each of the sensor nodes are clients on a local area or controller area network that are all tied to what we refer to as the I node or integration node. The integration node performs many functions, one of them being to act as a gateway to a private TCP/IP wide area network or to the open World Wide Web. The sensor pipeline system has a cloud-based monitoring and control system. To access this system, you enter www.sensorpipeline.com into the address line of your computer's browser. It will take you to this login screen where you enter your username and password and then hit enter or login. Once into the Sensor Pipeline website, you see this screen, which is the Health Summary screen, provides a summary of the system status. If there was an alarm, only the component with the alarm condition would be displayed. What is currently shown is a listing of all the smart components that are on our Sensor Pipeline network, and it is showing that everything has a green or OK status. At the top, it shows the status of the leak detection sensors, status of the impact detection sensors, status of the sealing force sensors. As shown, the system is currently set up with the impact detection sensors turned off. The sealing force sensors detect if a sudden drop has occurred in the compression force that is applied to the seals. So if someone loosens up a flanged fitting, a sealing force sensor will go off. The system displays current status and latch status. The component status provides more information on all the components. In one screen, it shows the leak, impact, and sealing force status of all the devices, even if there's an alarm condition. Geographic referencing is provided by clicking on the word map. It takes you to the map that shows where that particular component is located, and it gives you a summary of the status. It gives you some information about the particular component. If I go back to the component status screen, it shows that I can hit the maps on any of these components. If I go back to the health summary, you'll notice that there's also a map, the same map for each of its components. If I go to the geographic mapping button, it shows the map of where the smart components are located. And if you click on the point of interest icon, it shows the information for that particular smart component. Performance history. This is showing the performance history of the system. This is just an example of a system that shows that 94% of the time, the overall system had an OK status with no leaks, no impacts, and no seal loosening. You can expand upon this and show it by subnet. The performance history is a portion of the sensor pipeline web interface that will, in some cases, be tailored or modified to satisfy customer needs. Customers with existing analytical data systems or SCADA systems may be interested in accessing these systems or its data by hitting a button within the performance history. System setup. This is the most extensive portion of the cloud-based controls, and what it does is give you the flexibility to set up the sensor pipeline system according to how the hardware and system is configured. This includes being able to set up subnet servers and their IP addresses, inodes, sensor nodes, host cloud computers. Messaging setup allows you to set up messaging through email so that if a particular alarm condition occurs for a particular component, it would send out alerts to all those listed using email or text messaging. Under user setup, you can define users and associated privileges. The system setup option is not displayed unless you are logged in as an administrator. If I am logged in as a user, this functionality doesn't present itself.